Hey, welcome back everyone. Today we have probably a kind of a long video, I'm guessing, because we have a lot of information to cover, but it's also going to be a really fun video because we're going to be talking about everyone's favorite topic, which is graphics. In particular, user-defined graphics. Now, I mentioned about user-defined graphics a little bit in one of my previous videos, mentioning that we're probably going to be using them at some point in our game development journey. And I mentioned that they're kind of considered a somewhat primitive way of making graphics. But since then, I've actually changed my mind about that, because even though we're not making fancy, complicated graphics using the display memory and so forth, I've found that user-defined graphics are actually quite powerful and useful, particularly in machine code or assembly language programming. So today we're going to be taking a look at how we can use user-defined graphics in our games. And it's going to be a lot of fun, and it's going to be a little bit in-depth, but it's going to be a good ride, so come along with me and let's get started. Alright, so first let me start off by showing you my program that I've created that we're going to be going over today. And if you take a look on my screen here, as I scroll through it, you'll notice it's a very long program, particularly compared with the other programs that we've looked at on my channel so far. But we're going to go through pretty much every line of this program, and we're going to see exactly how it all works, and it's not going to be confusing by the end. And actually, even though the program is very long, I find that writing it this way makes it very easy to modify later and easy to use. So I'll show you how I created my program, and if you like, you can create your programs in the same way or use, of course, whatever method works for you. But let's go ahead and take a look at my program. And we'll start at the bottom as we normally do. But in this case, we have something a little bit different on the bottom, because if you see here, my bottom section is actually labeled UDGs, which of course stands for user-defined graphics. And by the way, of course, I'm using the ZX Spin emulator environment on my computer today for this example. And if you're not familiar with it, there's a video that you can watch to find out how to install it and how to use it. And it's the one I've been using for pretty much all of my demonstrations up to this point. So I'm quite happy with it. It's been working well for me so far, so I'm just going to continue on using it for now until I need to use something different. So let's take a look at this program now. And if you haven't watched my previous videos on assembly language, I've made maybe about 10 or so by now, I think. So if any of the information in today's video seems confusing, then I really recommend you go back and watch the previous 9 or 10 videos that I made, because they will explain everything in step-by-step that will make it clear what I'm about to explain today. So as you probably know, I separate my programs into different modules, and we're going to take a look at the modules first so we know what this program is all about. So first, at the very end of my program here, I have a section called UDGs, which stands for user-defined graphics. And over here I have a label called underline UDGs, which just helps me to find it over in the symbols listing or the label listing over on the left side of my emulator here, or my assembler. And let's see what's in this section. So here is where I define all my user-defined graphics, and we're going to be taking a look at this section a bit later, but I just wanted to let you know that I've got the data for my user-defined graphics at the end of my program. Just because it's so long, when you're looking through the listing, you probably don't want to scroll through hundreds of lines of user-defined graphics data. So that's why I like to put it at the end. But we're going to be taking a look at this in more detail a bit later when we actually design the graphics, which is really fun. Before we get to that, let me just go through the rest of the sections of my program here. So above the user-defined graphics section, I have this long section here that you can see has all these EQU statements here. And what these do is, well, this section first of all is called control codes, and this is a section that I find really useful. I don't know if other programmers use this type of section or not, but for me I find it so handy, and we're going to be taking a look at this in detail later, and you're going to see exactly why this makes it so much easier to program, at least for me, and particularly for beginners. So what I'm doing here is basically, all I'm doing is creating a whole bunch of different labels, and I'm assigning values to them. And the values that I'm assigning to them are simply the codes. And all this does is help me to not have to remember the different codes that I need in different parts of my program. For example, you can see here, these lines here assign codes to the different colors. So instead of me having to remember the number for a color, for example, I just type in these words. I can type in black or blue or red, so forth. And you can see there's different control codes up here, such as ink, paper, flash, brightness, and so forth. And these codes, let me just bring over my user manual here. And so this is the basic programming manual that comes with the 48K Spectrum, I believe. I'll just show you the front page of it. So it's this manual here, ZX Spectrum Basic Programming Manual, 2nd edition. And down at the bottom, or near the end of the book, it has a section here with all the character set and the codes for the different characters. So all these codes that I'm using in my program, so here you can see all these ink, paper, flash, carriage return is up here with a code of 13, and all these different codes at the top here I'm using, even the positional codes here, at and tab, they are all from this manual. So you can see here, the code for ink is 16, paper is 17, flash is 18, and so forth. And even the positional codes here, at and tab, they all have their own codes, 22 and 23. And we did cover this in a previous video where I talked about how to print to the screen. And if you haven't watched that, you might want to go back and watch that if you're not already familiar with that information, because it's going to be very important to know that information for today's video. So I just wanted to show you where I'm getting the codes that I'm using for these statements in my program here. So instead of having to type out the number codes for the different colors and the different control codes, I can just type out these names that I've assigned, which are a lot easier to remember. But there are some new ones that I want to familiarize you with now, so you'll have a hint of what's coming. And down here you can see I've got all these codes starting from UA and going down to UU. And what these are the user-defined graphics, characters, and codes. And let me just bring the manual back here for a moment, and I'll show you that. So if we take a look here, you can see starting here with character code number 144, these are the user-defined graphics, as it says right here. So these user-defined graphics range from code 144, right here, through to code 164. And those codes correspond to these letters, A through U. So as you know, the Sinclair Spectrum computer has codes assigned to every key on the keyboard. So all the alphanumeric keys and the characters and everything that it can print on the screen has these ASCII codes assigned to them. And that includes these user-defined graphics characters. So all these characters here with the codes ranging from 144 through to 164, these are the user-defined graphics characters that we're going to be taking a look at today. So there's 21 of them. And what these are, if you don't already know, these are characters where we can actually redefine the patterns for them in the computer memory. All these other codes and characters, they're pretty much hard-coded into the computer, and we can't change them. But these user-defined graphics characters, we can. So for example, you can see that the character 144 corresponds to an A, character 145 corresponds to a B. So those are the default patterns that are stored in the computer memory right now when you turn on your computer. So if you print a character 144, for example, it will print an A because that's the default pattern for the user-defined graphics character A or code 144. So what we're going to be doing today is actually redefining these graphics characters. Now, one thing I want to show you is where these patterns for these characters are stored in the computer memory by default. And we're going to take a look at a system variable that shows us where they're located. And although we're not actually going to be technically modifying the patterns for these codes in memory, we're actually going to use a kind of a trick to make up our own graphics rather than going in and modifying the graphics that currently exist for these characters, which you'll understand a bit later what I'm talking about. And if we take a look at this again, I want to show you a different section, which is this section here on chapter 25 called the system variables. Now, you're probably already familiar with system variables, but just in case you're not, the system variables are memory locations in the computer that store values representing different things that the computer needs to know. And one of the things that it needs to know is where the patterns for the user-defined graphics characters are stored. And that is held in a memory location which corresponds to one of these system variables. So let's see if we can find it. So let's see where it is. Right here. So if you see here, the name of this system variable is called UDG, which stands for user-defined graphic, of course. And it says here what it does. It says address of first user-defined graphic. You can change this, for instance, to save space by having fewer user-defined graphics. So this address here, actually these two addresses, because this address contains a 2-byte address, which tells us where the user-defined graphics are stored in the computer memory. So the way we would figure out what address these user-defined graphics patterns are stored in memory is we would take these two addresses, 23675 and 23676, and we would take the values from those two memory addresses, convert them into a 16-bit value, and that will give us our memory address. So let's just do that now so we know how to do it. Alright, so I have my emulator here, and those two addresses that we're interested in are 23675 and 23676. So the first address stores the low byte, and the second address stores the high byte. So we need to take the low byte and add that to the high byte multiplied by 256. So we won't need to be doing this today, but I'm just going to show it in this video just for the sake of completeness, so you have a record of it and you know how to do this. So I'm just going to show you the formula that we would use if you wanted to find out what the address was. So I'll just type it in here. Alright, so this is the formula that we would use if we want to find out the address where the first byte of the pattern for the user-defined graphics is stored in memory by default, and it's peak 23676 times 256, because that's the high byte, plus peak 23675. So whatever the value that's contained in those two memory addresses, they're going to combine to form another address which stores the beginning pattern of the user-defined graphics. So I'll just run this and we'll see what address that is. And the answer is 65368. So that means the patterns that are stored in memory for the user-defined graphics start at address 65368. Although, as I mentioned, we're not going to be needing this information for doing it in assembly language, which is a good thing, but this is useful information to have, so now we have it. Alright, now let's get back to my program here, and we left off looking at this section where the user-defined graphic codes are stored. So just to give you a preview of what we're going to be learning later on in our video, is these values here that I'm assigning to these labels. For example, UA here is getting a value of 144. And the reason it's getting a value of 144 is because if we look back at our manual here again, we will see that code 144, which is right down here, right here, corresponds to the user-defined graphic A. So what this is going to do is it's going to allow me to use a label instead of having to remember this code 144 represents the user-defined graphic for A. So if we go back to my program again, we can see here that now instead of me having to remember 144 here, I only need to remember UA, which stands for user-defined graphic A. And so I've assigned values for each of the different user-defined graphics characters ranging from A through U, because that's the last character that we're able to redefine in the user-defined graphics set. It just ranges from A through to U. So that gives us 21 different graphics characters that we can redefine. So that might not seem like a lot of characters for us to use. 21 graphics characters doesn't seem like a lot, particularly since they're only 8 by 8 pixels in size. And you might think, well, to make up any type of sizable graphics image, we're probably going to want to combine some of these user-defined graphics characters together to make up a larger image, and that's going to use up even more of these characters. So we're going to run out of characters pretty quickly if we only have 21 to work with, right? That seems like a logical assumption. But as we're going to be finding out in a moment, that limitation doesn't actually apply to us because we're going to find an easy way to get around it, and it's going to make our programming life a lot easier. Alright, so that's this section of the program. This section called control codes, as I just explained, assigns codes to all of these different labels so I don't have to remember all these numbers. Now let's go up and take a look at the next section above this control codes section, which is right here. So this section is called strings. And as we took a look at in the previous video where we looked at how to print stuff to the screen, this is a section where I store different strings that I want to print to the screen. So what does that mean? So let's say, for example, we're creating a game, and somewhere in our game we want to print something to the screen. Now this doesn't have to be a string. I know a string is normally thought of as a string of characters, like a sentence, for example. Like, for example, press enter to begin. That's a string of characters, right? Now, the way we're going to be using a string, we don't actually consider it a string of characters that need to be printed sequentially in a row. When I refer to strings in my program, all it means really is a bunch of stuff that we're going to print to the screen at the same time. So if you take a look here, and we're going to be looking at this more in detail a bit later, this is just a brief introduction, but if you take a look here, you can see each section here is separated by this dotted line, and so each section separated by this line contains all the information for the different characters that we're going to print to the screen. And we're going to take a look at this a bit later. So we're not limited by just printing a string of characters like a sentence, so we're going to be printing whatever we want, basically wherever we want, and we'll take a look at that a bit later. So that's what this strings section is. It contains different groups of characters that we want to print to the screen. And just to make it clear before we leave, the reason that they're separated into different sections is because the way we're going to be using these different sections is everything in each section gets printed at the same time. So for example, let's say you have a section that has the player's name and the player's score, and if those two different items are in the same section, then every time we use that section of code, it's going to print the player's name and the player's score. So if for some reason you didn't want to print the player's name and the player's score at the same time, then you would want to split those up into different string sections. So we're going to be taking a look at this a bit later, but that's what this section does. And then the next section above my string section here is a section called values. And we discussed this in an earlier video where we talked about how we can simulate the use of variables or the functionality of variables in an assembly language program. So this particular program doesn't actually have any values that I'm storing into memory, surprisingly, but it's not actually a program. It's just kind of a demonstration to show you how we can use user-defined graphics. So this section happens to be blank. In this case, I just have a comment here to remind me what the section is for. But if I did have some values that I wanted to store, such as the player's score or the player's health or the player's strength or something like that, then this is where I would store those values, as we took a look at in the previous video. Now let's just keep going up here, and our next section here is called Rom Routines, and again we took a look at this in a previous video. And what this does, it's another kind of a helper section that I use to assign numbers to labels, so I don't have to remember the numbers. And in this case, you can see all these different numbers are assigned to these different labels, and these numbers and labels represent ROM subroutines in the computer memory that we can call to perform certain functions. For example, this one at the top here, I've given it a label called border, and it's located in the computer memory at address 8859. And what it does is it sets the border color. So instead of me having to remember the number 8859, all I have to do is remember the name border or the label border. And just to let you know, all these different labels that I have here, these are my template labels that I have for my program. I'm not going to be using all of these ROM subroutines in today's program, but I've just put them here because they're part of my template. And so for example, if we take a look at them quickly, you can see the top one is the border. It sets the border color. We're not going to be doing that today. The next one is a clear screen to clear the screen. We're not going to be doing that today. The next one is output channel to activate a certain output channel to indicate which part of the screen we want to print to. We will be using this one today. And then these three subroutines here, print num small, print num big, print num big 2. These are ROM routines that allow us to print numbers to the screen. Again, we're not going to be using those today. And then finally, this last one here called PRINTSTRING. This one, as you can see by the comment here, prints a string to the screen. And the way it prints it is we need to load some values into the DE and BC registers, particularly the start of the string and the length of the string, which we looked at again in the previous video. But we are going to be looking at this one again today because we are going to be using this print string ROM call today. Now let's just keep going up and see what else we have. We have another section here called Sysvars. Again, this is a helper section where I'm assigning a number to a label. And this number is the address of a system variable. In fact, it's the address of the system variable that we just took a look at for the user-defined graphics. And I'll just bring that back here. So right here, we took a look at this system variable that is called UDG right here. And it has a number 23675. So that's the address, well, actually two addresses, 23675 and 23676, that store the location of the user-defined graphics. And we are going to be using this address, 23675, and if we go back to my program now, you can see that's exactly the number that I've used here, 23675. So again, I'm assigning this number to this label UDG pointer, just so that when I'm writing my program, I'm able to use this label name UDG pointer instead of the assigned number, which is 23675, because obviously UDG pointer is a lot easier to remember than 23675. So let's continue on to our program now. And so the next section above that is my section where I have my subroutines. So my program contains a main program loop, and it contains a separate section for the subroutines. And we're going to be looking at the subroutines obviously a bit later. So above the subroutines section is the main program loop here. And you can see my main program loop, all it does is it calls subroutines. So there's no code in my main program loop in this particular case. All it's doing is calling subroutines, and the subroutines is where I have my code that actually does stuff. So I know it's kind of involved to take a look at how my program is laid out this way, but you're going to see, even though this program seems to be laid out in a very kind of long, possibly confusing way, when we're actually using it, it makes it super easy to make changes and adjustments as we're using it. And it also makes it very easy to troubleshoot, and it's very easy to do testing and to do modifications. So that's why I like making my programs as modular as possible. And as you can see, I've got them commented like crazy. Pretty much every single line has a comment. You can see all these gray sections here are comments. And so I do recommend that you comment your code as well, because it's really helpful to be able to figure out what these lines of code are doing later when you can't remember. Okay, so now let's take a look at this program in detail, and we can see how we can use user-defined graphics to really punch up our programs with some graphics and make them really cool. And actually, if you can understand everything that we're doing in today's video, you're going to have a good head start in at least creating some simple graphics for your games. And just to give you kind of a teaser of what you can do with these types of graphics, I'll show you a game that I'm working on so you can have an idea of what kind of graphics we can create using this method. So I'll just bring it up here. And here's part of a game that I'm working on right now. It's my first game, and it's a secret, so don't tell anyone. But these are some of the graphics that I've been able to make so far. And if you take a look at this screen, I'll just show you one part here. And this is written for just a regular 48K Spectrum computer. And we all know the color limitations on the Spectrum computer for the attributes. You can only have 2 colors on a regular Sinclair Spectrum, one paper color and one ink color. But if you take a look here, for example, this heart that I have, you can see it has a red heart with a blue background and a black border on the left and the top and a white border on the bottom. So that's 4 different colors in close proximity that might give the impression that they're all in the same character square, but actually they're not. Just by some clever design, I made it look like they're close enough that you would think that all these colors are kind of living together, but they're actually separate, and we're going to show that in detail a bit later as well. So this is just a kind of a quick example of the kind of graphics we can make with user-defined graphics. And of course you can make much better graphics than this. This is just my quick example that I made to start off my own game. And that's my sneak peek. Again, don't tell anyone about that. I'll let you know once the game is finished, but let's get back to my program for now. And the graphics we're going to be making today are a little bit different than these, but they're similar. So you can have an idea of what's possible with user-defined graphics. Now let's actually get into the program and see how we can really use user-defined graphics. Now the first thing we want to do before we learn how to program using user-defined graphics is we need to design some graphics. So let's take a look at a graphics program and actually design some graphics so we get them ready for our program. Most of the work of actually creating a game is the preparation stage, designing the game, designing the graphics, designing how the program is going to flow and so forth, and figuring out how we're going to actually make it. So now we need to design some graphics, and I'll show you how I do it, so let's get to it. Alright, so let me show you the graphics that I'm going to be using in today's video, and I'll just bring them over here, right there. So these are the graphics we're going to be creating in our program today. We're going to be creating some user-defined graphics, and these are the graphics we're going to make. And if you take a look at the screen here, you can see these red lines separate where the borders of each character are. And first of all, let me just tell you, I'm just using a free online pixel art program that you can use. It's at piskelapp.com, piskelapp.com. And this program is called Piskel, and you can see here it's called Piskel. And it's a cool little program if you want to make some quick graphics. This is a fantastic way to do it. And I'm not going to get too involved in the program today, teaching you how to use the program, but I am just going to use it a bit today to show you how we can use it to make our graphics. So if you want to use this program, you can, or you might have a better way of designing your graphics. It's up to you how you want to do it, but this way works just if you want something quick and dirty kind of way of making graphics. So let's just take a look at how this works. So I'm just going to change the settings here so that I'm going to increase the grid size a little bit so we can see exactly where our characters start and stop. So if you take a look here, these red outlines outline the different characters that we're going to be redefining. So in this case we have 9 different squares representing 9 different characters that we're going to be designing. Well, I've actually designed them already in my program, but I just wanted to show you how I did it. So in this program, all I did was I designed the characters or the graphics in this program, and I set it up so that it's laid out in these different squares. So for example, if I go here to this resize icon over on the right, I can set the size of my screen here. So for example, if I set this to, let's say, 40 characters wide by 24 characters high, that should give us 5 characters across by 3 characters high. But I only need 9 characters, so let me just set this to 24 by 24. There. So these are the 9 characters that I've redefined. And the way I program them is very easy. I can zoom in and I can zoom out. And for example, if I zoom in here to my middle one, all I need to do is select a color over here. Let's say I select this blue color here. Then I can set the colors on the screen. Very easy, just like editing any other pixel art. So I'll just change that back. So you can see here I have 9 characters designed, and the top 3 characters actually are a shrunken version of text. So you can see I have 2 letters squeezed into 1 character space here for the H and the E, and then this middle one has the A and the L, and then this right one has most of the T and the letter H and a colon. So I'm going to be using these 3 graphics characters to write a smaller version of the word health instead of using the built-in text in the computer. And then the next line of graphics in the middle here are 3 faces, a happy face, a sad face, and a surprised face. At the bottom here we have 3 landscape type graphics. This left one is a tree, this middle one is a church, and this right one is a factory. So these are the graphics we're going to be using in our program today. Now let me show you how I get them into my program. So I'll just move my program over here and I'll scroll back down now. We'll take another look at that UDG section that I showed you at the beginning of the video, which is right here. So you can see here I have this section called UDGs, and the way I've split it up here is I have different sections for different types of graphics. Now how the graphics work, well, how the user-defined graphics work in the Sinclair Spectrum computer is the computer reserves 21 character spaces for graphics, just like we took a look at. We have the characters A through U, so that's 21 different characters. The only difference in our program is instead of redefining the patterns in the existing computer memory for those characters, we're going to be telling the computer where to find our patterns. So we don't need to worry about where the default patterns are stored. We're going to create our own patterns in memory, and we're going to point the computer to look at our patterns wherever we have them stored. So that's a great flexibility, and how that helps us is as we constantly change the pointer for where the computer graphics are stored, then we don't have to worry about a limitation of how many graphics we can create, because we can point to whatever memory address in RAM that we want to, right? So we can define more than 21 characters in this case and just keep moving the pointer around, and we're going to take a look at how we do that when we take a look at the program. So let's start off by programming our patterns, and the way we do that is I have my section here labeled UDGs, and I put a label here called UDGs. You don't need this label. That's simply just for me to be able to find this section easily by double clicking on the UDG label over in the left hand column here, but you don't need to have this label if you don't want to. These other labels though you will need. They're going to be critical to have in the program, otherwise the program won't work. So this label here called FACEUDGS, this is a label that's going to automatically get assigned a memory address when this program gets assembled, and that address is going to be used when we run our program later to change the pointer that the computer uses to find our graphics. So what I've done here, you can see I've got this FACEUDGS label here, and then it's followed by these different patterns. And the way I've stored the patterns in memory in the computer is I've used these defined byte statements here. DEFB stands for defined byte. It stores information into the computer memory. And then you can see I've got a percent sign here. The percent sign represents binary. So that means when I use a percent sign, the computer is going to expect me to enter a binary number, or rather the assembler is going to expect that percent sign to be followed by a binary number. So normally when I enter values into the assembler, it expects a decimal number. If I use a dollar sign, then it will expect a hexadecimal number. So in this case, I'm using a percent sign, which indicates that I'm going to be using binary numbers. And the reason I'm using binary numbers is because it makes it easier for me to transfer the pattern. So if you take a look back over here at my art program, I'm just going to zoom in on one of these characters. And let's say I zoom in on this red face here, and I'm going to change the settings now so that we have borders between the individual pixels. You can see right now these red outlines are showing the borders between individual characters, but let's say I want to separate the pixels so they're easier for me to count. So I'm just going to go to my settings here and change the grid spacing to 1 pixel, and I'm going to change the color to, let's say, green. So there you can see our pixels now are separated by these green lines, and now we can't tell where every character starts and stops anymore. We can't see the boundaries between the different characters, but that's okay because I know where the characters are anyway. So I can tell that this red face takes up one character position, for example, and it's up to you if you want to use this program or use your own method, but the way I've done it is I've decided to enter them in binary, and now I can simply just look at this pattern and see where the ones and zeros are. And if black is the paper color, and that represents 0, and red is the ink color, and that represents 1, then the top line of this pattern would be 0, 0, 1, 1, 1, 1, 0, 0, which is exactly what I have in my program right here. 0, 0, 1, 1, 1, 1, 0, 0. So all I've done is gone through all of these patterns, transferred them into these defined byte statements as binary. Now if you happen to be using a tool that converts your patterns into decimal values, then you don't need to use binary. You can just use decimal values if you like. But in this case, I'm showing you how I use binary patterns. And of course, it's very easy for me to go back and change them now. I can kind of see what the pattern is using these binary ones and zeros. And I can just change this pattern as I need to modify the graphics if I want. So that's how I've transferred these patterns from my graphics program into the assembler by using these defined byte statements with binary values. So I'll just move this pattern back here. And now let's take a look at our program again. So you can see here I have a comment called happy. So this is going to be the happy face. And in brackets here, I've also put a note indicating what character this would correspond to. So for example, the normal user-defined graphics A in this case would be my happy face. And down here I have a sad face, which would be the user-defined graphics character B. And this one would be the oh, my surprised face is a B still. I should change that to C, because that's a C. So the user-defined graphics range normally from the letters A through the letters U, but I'm redefining them in this case as happy faces and other characters. But these letters indicate what the normal keys would be in the user-defined graphics set by default. So you can see I could use the characters A through U and have 21 different characters that I could redefine all in one section here. But if you take a look here, I have a face UDGs section that has a happy face, a sad face, and a surprised face. And then I have another label here which is called Scenery UDGs, and it has a tree, a church, and a factory. And then I have another section called Small Text, and that contains all the miniature versions of my text that I'll be defining as well. So in this case I only have 3 different characters in each of these sections. Instead of using all the 21 different characters that are allowed to me, I don't need to use all the 21 characters. I can have as many characters as I want in each section up to a maximum of 21. Now let's take a look at the program and we'll see how I actually use these characters. And let's start at the beginning and we'll take a look at our main program loop. So here we have our main program loop. And remember what the goal is for this program is to print user-defined graphics to the screen. And in order to do that, we've already entered the patterns for our user-defined graphics into the assembler, and the assembler is going to automatically assign memory addresses to the labels that are the headers for each of the sections where our patterns are stored in this program. So now we're going to see how we use those. So in our main program loop here, I have only 3 lines of code. and all they do is call subroutines, and let's see what they do. So the first line is going to call a subroutine labeled sub1, and it's going to print the faces. The second line of code is going to call a subroutine called sub2. It's going to print the scenery. And then the third line of code is going to call a subroutine called sub3, and it's going to print those small text words that are going to spell out the word health. And so we'll see how that works right now. So let's take a look at our first subroutine. The first line of code in our main program loop is going to call sub1. So let's take a look at sub1. Here we have sub1 right here, and it says print face graphics. So this subroutine is going to print those three smiley face graphics that we have over here. Right here, this blue face, red face, and green face. Let me just change this grid size back so we can see where our grid is again. Okay, so here are the characters we want to print. We have three characters that are going to spell out the word health. We have three faces, and we have three landscape items: a tree, a church, and a factory. So let's take a look at our program here. So subroutine 1 is going to print the faces, which are these three faces here. So let's see how we do that. So the first line in this program, it says load HL, face UDGs. So what it says it's doing there is it says it gets the location of UDG data. So what this line here is doing, load HL, face UDGs, is it's taking the value that's stored in face UDGs and loading it into the HL register pair. So what is this value face UDGs? Well, if we go down to our UDG section, here's face UDGs right here. So face UDGs is a label that points to the location in memory where we're storing the patterns for our face graphics. So if we go back to our subroutine, the first thing we do is we find out where those face graphics are stored in memory, and we load that into the HL register pair. And so let's take a look at the next line now. In the next line, what we're doing is we're taking that location where our patterns are stored, and we're injecting that value into the system variable that keeps track of where the UDGs are. So now we're kind of tricking the computer into thinking that the UDGs are stored in a particular location when actually we're pointing them to look at our UDGs. So that's what we do right here. We take this value that's in HL that we just loaded into HL, and that value is this face UDGs memory address where we have our pattern stored. So we're taking that pattern memory address and we're loading it into the system variable that points to the UDGs, which is this UDG pointer label here. And if we look back at our system variable section, right here, we have our UDG pointer label right here, which equals this memory address 23675, which we don't really need to worry about what number this is, as long as we have it assigned. It's going to take our memory address locations where we've stored our patterns, and it's going to load that location into this system variable to tell the computer where to look for the user-defined graphics. So in this case, it's going to look for the user-defined graphics where we've stored our face patterns. And that's what this line here does. It tells the computer where to find the patterns that we've stored for our face graphics. And now these next two lines we should be familiar with because we looked at them in the previous video on how to print to the screen. These two lines are used to activate the upper portion of the screen, which is output channel 2. So I don't need to go into too much detail about these two. You can look at the previous video if you don't understand how these two lines work. And then these next three lines we also looked at in that same video, how to print to the screen. These ones will take a string of data or a string of characters, and it will output them to the screen. So the way it's doing it is, just for a quick review, in this line here, you have to tell the computer where your string begins in memory. And so my string begins at this label address called string1, and I'll show you that in a moment. And we need to load that into the DE register pair. And then we also need to load a value into the BC register pair, which is the length of our data that we want to print, or the length of our string that we want to print. And the way we do that is by using this formula, which we covered in the previous video, which automatically calculates the length of our data by using the end address of our data and subtracting the beginning address of our data. So that gives us the length, and we need to store that into the BC register. And then finally, in order to print our string to the screen, we simply call this PRINTSTRING ROM subroutine, which we've allocated down here in our ROM section. You can see right here we have our PRINTSTRING subroutine that's assigned a numeric value which points to the memory address where this particular ROM subroutine is located, which prints our string to the screen. So if we go back to our subroutine, just as a quick review, what we're doing is we're grabbing the location in memory where we stored our pattern. In our next line, we tell the computer where to look for our pattern by reassigning the system variable for keeping track of where the UDGs are located. And then these last lines of code simply print our pattern to the screen. So now let's take a look at exactly how we're printing our pattern to the screen. And we're going to see exactly why all these values that I assigned down here in this section here called control codes, all these values here where I have particularly all these color values assigned and also these control codes for brightness and paper and ink and flash and all that, that's going to come in very handy right now, as we'll see. So let's go now to our strings section, which is right here, strings. And this is where we have all the different characters that we want to print to the screen. So our subroutine number 1 that we just looked at is going to use this string1 subroutine, or str1, to print our first string to the screen. And we can take a look at the comment here which says face graphics string. So this section stores the graphics for those faces that we want to print to the screen. And let's take a look at exactly what we're storing here. So this information we covered in that previous video as well. So you might want to take a look at that one if this is confusing. But let's take a look at how those codes, and particularly the labels that we've assigned those codes to, are helping us now. So if we take a look at the first line here, you'll see we have a whole bunch of different labels and some numbers all separated by commas. And those are the different characters that are going to get printed to the screen by this ROM subroutine that we're calling. So let's take a look at the characters in the first line here. So we have our define byte statement, followed by the first character, which is underline at. So underline at is one of the codes that I assigned, which is right down here. Underline at equals a value of 22. So that's simply the at statement, just like in the basic programming language. When you print at a certain location on the screen, that's what this code does. It prints at. So if we go back to our string section here, the first line here is telling the computer to print an at control code. So it's telling the computer we want to print at a particular location on the screen. And what location do we want to print at? Well, we just simply take a look at the next two numbers here, 7 and 11. So 7 is the Y coordinate, so how many lines down from the top of the screen, and 11 is the X coordinate, or the column starting from the left hand side of the screen going to the right. So we're going to print at position 7, 11. So the next codes we have here are all the labels that I assigned. So you can see we have ink, red, so it's going to print in red ink, and then paper black, so the paper will be black, and then flash will be off, the brightness will be on. And if we take a look at all those different codes, you can see they're right here. So we have flash, brightness, off, on. So off and on, I've just assigned values of 0 and 1, although I can easily remember 0 and 1 represents off and on, but it's just kind of neat to assign them off and on codes like that. And then of course we have all our colors, black, blue, red, magenta. So we can use all these labels now in our string section, which we're doing right here. So now isn't it a lot easier to enter these labels instead of having to remember which code represents ink, which code represents paper, which code represents flash and all that. So here we can easily see we're going to be printing at location 7, 11 with ink that's red, paper that's blue, the flashing attribute is off, the brightness attribute is on, and then the final thing here is UA. So do you remember what UA stands for? Well, that is the label that I've assigned to represent the user-defined graphic of A. And the reason I'm using A, B, and C here, even though we're not printing A, B, and C, we're not pressing A, B, and C on the keyboard. So why do we need to know A, B, and C? The reason why we need to know that is because the computer still has that limitation of having only 21 different locations where we can assign a set of patterns for user-defined graphics. So we can only have 21 different characters assigned at any one time. So if you take a look at the different string sections here, this one prints the face graphics, this one prints the scenery graphics, and this one prints the small text graphics. But you can see at the end of the line, they all use the same A, B, and C characters. So here A, B, and C, and this one, well, the last one's a bit different. We'll look at that one in a bit more detail later. But you can see, take a look at the first two, for example. The last characters are UA, UB, and UC, and then again UA, UB, and UC. So the first section is printing the faces, and the second section is printing the scenery, but they're both printing user-defined graphic characters A, B, and C. So how can that be? How can that work? Well, the reason that works is, if you take a look at our printing subroutines, each printing subroutine redefines the location where the graphics are stored. So that's what we're doing here. You see, we've taken this FACEUDGS address where we've stored our patterns, and loaded it into the HL register to print the faces. And then in our next subroutine, which prints the scenery, it takes the scenery UDGs label and takes that address where we've stored our scenery patterns, and it loads that into the HL register. And then finally, when we're printing our small text graphics, it takes our small text UDGs label where we've stored the patterns for our small text graphics, and it loads that into the HL register pair. So what we're doing in each of these different subroutines is when each subroutine runs, each subroutine wants to print a different set of graphics. The first one prints the faces, the second one prints the scenery, and the third one prints those small graphics characters. And in order to do that, it redefines the system variable that tells the computer where to look for those graphics. So every time we redefine that variable, the computer is going to start off again from character A, B, C, right? So if we didn't redefine the location of those characters, let's say we only told it to point at, for example, the first character, which was, let's say, this one, FACEUDGS. In that case, what would happen is this happy face would be character A, the sad face would be character B, this surprised face would be character C. But then if we go down here to our scenery section, let's say we didn't have this label here, right? So we have no way of pointing to this scenery section. The computer would just consider all of these user-defined graphics to be contiguous one after the other. So then this tree here would actually be letter D, and this church here would be letter E, the factory would be letter F. So in this case it would be fine because we are not using up all 21 different graphics. So I didn't have to split them out into 3 different sections, but by splitting it out this way, it gives me more room to assign more graphics for each section. And if we go back to our string section here, and we'll just finish looking at our first string section where we're printing the face graphics here. So we just took a look at the first line, and it's going to print at location 711 with all these different color attributes and flashing and bright attributes. It's going to print the character A. And then the next line here is going to print with all these attributes and printing the character B, which is a sad face. And then the third line here is going to print the character C, which is a surprised face. And remember, these different lines are not actually doing the printing. All these lines are doing is storing all these codes in memory. So the computer, when it runs this ROM routine to print this particular string, it's just going to extract all these codes one by one and print them, whether they're a control code, whether they're a character, whether they're a printable character or a positional character like the @ control code or the flashing attribute. It's just going to send them to the screen and it's going to do whatever they're supposed to do. So these individual lines don't actually do the printing, but remember, we're just storing codes in memory. And that's how it works. That's all it does. And that's the entire program, believe it or not. So we just have 3 different subroutines here, sub 1, sub 2, sub 3. They all get called in order. And what they do is the sub 1 prints face graphics, sub 2 prints scenery graphics, sub 3 prints small text graphics. And before we run this program, and I am going to run this program very soon, so don't get too bored yet. And I just want to show you one more thing in our strings section. So now if we take a look at this small text graphics string. So again, this section is going to store all the codes and characters for printing these small graphics right here. These tiny letters that spell the word health, although they're all mashed together onto the same character, so we have 2 letters combined in the same character square. That's okay because I don't need them to be split up. I don't mind if they're together in the same character square. I can still print them, right? I'll just print them as one character because I know what I need to print. So this is useful if I'm using it, for example, in a game where I don't need to print a whole bunch of different words. I just need to print maybe a few different words, like maybe health and strength and so forth. I can just program them as user-defined graphics. So let's take a look at this program again at this string section where we're printing these small words, these small text graphics. And the first line here you can see, we can tell by looking at all these different labels exactly what this line is doing. So it's printing at location 1310, ink cyan, paper is black, the flashing is off, the brightness is on, and now it's got 3 characters here, UA, UB, and UC. And if we take a look down at where we program those characters or save them in memory, right here, we can see that the A character represents the HE pattern right here, and then the B character represents the AL, and then the C character represents the TH. So there's our HE and our AL and our TH, And then the last thing we want to look at before we run this program, I promise, is this last line in our string 3 section here. So what's this one doing? Well, if we take a look at the code over here, you can see in my comments rather, the top line says it's printing these 3 characters, HE, AL, TH. Those are the different patterns it'll be printing. And then this next one says it's going to be printing a health value. So can you figure out by looking at this last line what it's going to be printing, what it's going to be doing? Well, it's pretty easy to see that it's going to be printing something at location 13, 14 on the screen, which is position 13 down and 14 across. And then it's going to be printing in an ink color of green and a paper color of black. And the flash attribute will be off, the brightness will be on, and it's going to print this string right here. So this 100 in quotes, it's going to print on the screen. Now this 100 is obviously not really a number, it's just a string of characters that spell out the word 100. So it's not a number that we can manipulate. And obviously if I wanted to, I could print an actual number on the screen using the tricks that we learned in a previous video of how to print numbers on the screen. But in this case, I'm just showing an example of how it looks and how we can combine some numbers with our user-defined graphics. And so we're just going to pretend that this is a number that represents our health value. Alright, so now's the time we've been waiting for. We're going to go ahead and run our program and see what our user-defined graphics look like. So I've just entered a short basic program here to change the border and paper color to black because the characters look cooler when they're on a black background. And then I've got some other lines that change the colors back to white after the program is finished running. So let's go ahead and run it now and see how our graphics look. And there you go. That's pretty cool. So you can see we have our 3 different sets of graphics, our faces, our landscape, and our miniature health word spelled out here. And you wouldn't know that these are actually 3 characters stuck together, but they are, and it looks really good. And here we have just the regular Sinclair characters spelling out the number 100. And I think that looks pretty cool. And obviously you can make much more complex patterns, as I've shown you before, such as the game that I'm working on, which is only slightly more complicated than this one. But before we go, why don't we take a look at how easy it is to modify this program if we want to make some changes. So let's say you're making your own program and you've gotten this far and you've actually designed some graphics and you've got them printed on the screen, but maybe you're not really happy with the way they look. Let's say we want to change something here. Actually, these look pretty good. I'm not sure what I would want to change, but let's say we want to make this factory down here a little more visible. So let's go back to our program here and we'll find our factory user-defined graphics section. Actually, we want the strings section, which is right here. So where do we print our scenery graphics? Well, we can easily find that right here. Scenery graphics string. And where is our factory? Well, that's easy to find as well because it's right here. We've labeled it with the word factory. And now what do we want to change? So let's see, the ink right now is magenta. Why don't we change that to yellow by just typing YEL. And now we want to change the paper. Let's say we change the paper to blue, BLU. And the flashing is off. We'll leave the flashing off, I think. And the brightness, why don't we turn the brightness on? Like that. And then, actually, why don't we print 3 factories? So we can easily do that by just putting another comma here. And then following that with another UC character, which stands for User Defined Graphics C. And then we'll put a 3rd one. Actually, why don't we put a tree after it? So now we have 2 factories and a tree. So the tree is right here, which is character UA. So now we just enter UA. And now we should be printing 2 factories and a tree. But maybe we don't want our tree to have yellow ink on blue paper. Maybe we want the tree to have green leaves on a black background. So we can change that easily as well. We'll just precede that with ink, comma, green, GRN, and then paper, comma, black, BLK, just like that. And now we can assemble it and bring our emulator back. And now when we run it again, let's see what happens. There we go. Now we have 2 factories that are printed in yellow ink on blue paper, and we have a nice green tree next to them to give them some scenery. There, so hopefully this introduction to user-defined graphics was useful for you. And now we have an idea of how powerful these user-defined graphics can actually be in our assembly language programming. And if you lay out your program exactly the way that I've done, I think you'll find it quite easy to use and easy to modify, as we just saw when we added those extra factories and the tree. And what I'm going to do is put a copy of the code for my assembly language program in the video description down below. So if you want to, you can use it as a template, and you can just copy and paste it into the assembler and run it for yourself and make modifications and play around with it if you want. Otherwise, I hope you've enjoyed this video, and we're going to keep going forward, and I'm just going to keep sharing with you any techniques that I run across as I find them, and if I find them useful, I'll share them with you. So there you go, there's some graphics tools for us to use in our game development journey, and hopefully you're well on your way to making your own game for the rest of us to play, and we look forward to playing it, and we'll see you in the next video.